Hello, my dear students of Benguet State University. Welcome to our online class. I am your teacher, Jan Lasea.
Ladies and gentlemen, a blessed day to everyone. This is my lecture on our laboratory subject of IT 128, Quantitative Methods. Today, let us study quadratic regression. A quadratic function is a function of the form y is equal to the function of f at x is equal to a squared plus bx plus c, where a, b, and c are real numbers and a is not equal to 0. The domain of a quadratic function is the set of all real numbers. If the coefficient a is greater than 0, then the graph of a quadratic function looks like in this figure A. It is a parabola, concave, that opens upward. If the coefficient a is less than 0, then the graph of a quadratic function looks like in figure B. It is again a parabola, concave, that opens downward. Use the decisions chart below to interpret the coefficient of determination r squared for quadratic regression. For example, the cricket chirp temperature, when modeled using quadratic regression, has 0.76, 50, 55 coefficient of determination. That means very high relationship between the two variables x and y, or the chirps per second and temperature in degrees Celsius. Therefore, it has a very high or strong prediction. The following codes are taken from the laboratory hands-on activity number 7 of the laboratory manual. The following GNU Octave codes will model the cricket chirp temperature using quadratic regression if it will fit. The variable y is a matrix containing the measured actual temperature in degrees Celsius. The variable x is a matrix containing the measured actual chirps per second. Using the built-in function polyfit, we pass the arguments x, y, and degree of 2 to determine the quadratic computational model. It prints the formula of quadratic function. The next commands computes and prints the coefficient of determination r squared. Finally, using built-in function polyval, it predicts the 40 chirps per second to temperature in degrees Celsius and displays on the command window. Which model you will choose between linear and quadratic regressions? Perform a close ocular inspection between the two graphs. If most plotted points are near to the line or curve, then choose that regression. Otherwise, if the points are far from the line or curve, then you would not choose this regression. If there are outlier points, then remove them, and only inlier points must remain. Compare the coefficients of determination r squared. Whenever is close or near to 0, the better the prediction. Likewise, compare the standard errors of estimate. Whichever is close or near to 0, the better the prediction. The linear regression has coefficients of determination r squared 0.76, 08, 01, while the quadratic regression has a coefficients of determination r squared 0.76, 50, 55. Both are the same. The linear regression has standard error of estimate 2.300796, while the quadratic regression has a standard error of estimate 2.2800249. Both are close and the same. The linear regression, the prediction for 40 chirps per second, has 68.9971 degrees Celsius, while the quadratic regression, the prediction for 40 chirps per second, has 121.72712 degrees Celsius. The linear regression model is better here, unless the place where it conducted the study is at the middle of Sahara Desert or near an erupting volcano. Let us run this laboratory hands-on activity number 7. After it printed the quadratic model and printed the coefficient of determination and calculated and printed the standard error of estimate, it draws a graph showing the quadratic curve alongside with the points of the gathered data. Let us look at closely the graph using GeoGebra. As we can see, the graph of the quadratic function is a parabola concave that opens upward. The coefficient of determination is positive, greater than 0. That's why it is a curve that opens upward. If we zoom in to the points and zoom in further, we can see that it is almost a line. It looks like a linear function. Here is your assignment. On pages 23 to 24 of the laboratory manual, solve the laboratory hands-on exercise number 5. If you are assigned set A, then solve set A. Otherwise, solve set B. I posted your laboratory hands-on exercise number 5 in our Google Classroom. Please answer and accomplish it.
That ends our topic for today. I hope you have learned in my class. Thank you for watching. Carry on until tomorrow. God bless us.